As part of a batch order through DigiKey, I recently picked up SparkFun's USB Breadboard power supply kit. This is a small and convenient drop-in module that connects to a breadboard and provides 5V and 3.3V power sources through a USB 2.0 Type-B connector. Though I had a great time building and using this kit, I also wanted to provide an analysis of the circuit, as I feel it could use some documentation for the novice kit builder at which it is targeted. While this is a fairly simple kit to work with, I still had trouble finding step-by-step instructions, and think a kit of this sort should educate the builder as well as serving a practical purpose. Here's the schematic as provided by SparkFun. So let's start at the left side of the image with the USB input. The USB 2.0 standard specifies a power source of 5V at 500 milliamps. The 5V line is connected through an SPDT style slide switch. The two data pins on the USB plug are left unconnected as they don't serve a practical purpose in this circuit. From here, we have two more components between the 5V input line and the LM317 input pin. R3 is a PTC type resettable fuse. This is similar to a thermistor and serves as a protection mechanism for the circuit. If the amount of current delivered exceeds 500 milliamps, R3 will cut the input line until the overcurrent is removed. Capacitor C1 then serves as a filter to cut high-frequency noise or ripple from the input power source. The circuit centers around the LM317 voltage regulator. This 3-pin IC can output up to 1.5 amps of current at voltages ranging from 1.2 volts all the way up to 37 volts. In our application, it'll accept the 5V source from the USB connector and output 3.3 volts from its output pin. The LM317 uses two resistors labeled R1 and R2 to set the 3.3V output voltage. This voltage is determined by the formula V equals 1.25 volts times 1 plus R2 over R1. Substituting the values of our resistors, this gives us 1.25 times 1 plus 390 over 240, which equals 3.28125 volts, which is within a 1% tolerance of our target of 3.3 volts. The resulting 3.3 volt line is then connected to two capacitors. C2 and C3 are 10 microfarad and 0.1 microfarad capacitors respectively, and are intended to provide ripple rejection and improve transient response. Completing this circuit, we have two more branches. One is to our power LED, which is marked as LED2 and is protected by a 330 ohm resistor labeled as R4. Finally, the other branch leads to JP3, which is our final 3.3 volt output. I don't have too much to say about the actual soldering process. It's fairly straightforward and should be a reasonable challenge for a novice. I would mostly suggest being mindful of the orientations of the polarized components. These are the LM317 voltage regulator, power LED, and electrolytic capacitors. There are two helpful guides for placing the components, those being the schematics and also the markings on the PCB. I hope this analysis has been helpful. Beyond the more obvious applications of this circuit, we should now also have a good idea of how this type of design could be adapted. For instance, we could swap the USB input with a 5V DC power supply connector, or we could alter the output voltage by replacing our two adjustment resistors with a pair using different resistance values. I suggest taking a look at the LM317 datasheet provided by Texas Instruments, as it provides some additional sample circuits and describes how this power supply could be easily converted to a battery charger with the addition of a shutoff transistor. To sum up, this is a great starter kit with practical value that can be had for under $20. In my case, I already have a computer with a USB port sitting on my bench, so I no longer need to use up an AC outlet for a wall wart power supply. It's great for anyone needing a quick 5V or 3.3V power source to their breadboard, and is an excellent way to learn about basic power supply design and the use of the LM317.